The NBAA Safety Committee SMS Working Group is pleased to present this educational video on Safety Risk Management, SRM, the core component of any effective safety management system. SRM is essential because it directly enhances your organization's overall safety performance and culture. Throughout today's discussion, we'll explore practical examples from Blue Sky's charter, a Phoenix-based operator managing a diverse fleet of aircraft, including one single engine and several jet aircraft. Each aircraft type presents distinct risks and opportunities, making Blue Skies an ideal case study for demonstrating the real-world application and benefits of safety risk management. In today's video, we will discuss some basic definitions of the terms that we will be using, the decisions that effective safety risk management will force you to make, and how best to communicate the SRM process to other concerned people and organizations, using scenarios based on Blue Sky's charter's operations. So, what do we mean when we call SRM the heart of a safety management system? Let's explore this by looking at Blue Sky's charter's operations. First, it might be easier if we use the name that a lot of other industries have adopted for SMS and other programs meant to protect the organization, its people, and its assets. They're called Enterprise Risk Management. Risk management is the point. An SMS should perform 4 basic steps. 1. Identify the system's hazards and their associated risks. 2. Mitigate the risks to as low as reasonably practical. ALARP. 3. Decide between the residual risk and hazard avoidance. 4. Learn from the experience. Everything else in an SMS supports or validates this process, as you will learn in the other presentations in this series. So, what do we mean by a hazard? FAA Part 5 tells us that a hazard is anything with the potential to cause or contribute to an aviation accident. ICAO's definition is only a little different, saying an incident or an accident. What are some examples of hazards? The easiest are thunderstorms or other weather issues, which we know have caused numerous accidents. How about an equipment failure? We could be talking about an aircraft engine or a ground radar or a piece of critical maintenance gear. Derived from the idea of a hazard, let's discuss risk, or as we might say, the risk that a hazard will cause an aviation accident or incident. Risk is the composite of the likelihood that a hazard will affect the flight and the severity of the threat that the hazard poses. So, let's return to our thunderstorm. Outside of the intertropical convergence zones, the likelihood of thunderstorms varies by the season, with the summer and monsoon seasons showing the highest frequency of these dangerous beasts. And I don't think that any of us would dispute the severity of a thunderstorm's threat, but the specific risks would include hail, turbulence, and lightning. Engine failure is a very different risk. Given that certain engines have a mean failure rate of about 1 every 2 million hours, there is very little likelihood that an engine failure will occur. Severity, on the other hand, varies by the type of operation. If you are a single-engine operator, an engine failure, especially on takeoff or over water, is very severe, while a multi-engine operator in the vicinity of an airport would consider an engine failure serious, but not particularly severe. Now that we have defined a risk, let's see about mitigating those risks. A mitigation is a means of reducing the likelihood and/or severity of a particular risk. For example, an operator could plan their routes so as to minimize their time in areas of significant convective activity, reducing the likelihood of a thunderstorm encounter. A single-engine operator who spends significant time over water might consider switching to a multi-engine aircraft or routing their flights so as to spend more time within gliding distance of land, both of which would reduce the severity of an engine failure. The goal of mitigation is to reach a point where the risk is as low as reasonably practical, or ALARP. James Reason defined ALARP as the point beyond which it is neither technologically nor commercially feasible to do more. Incorporating all of the protections into an aircraft that would be necessary to keep a thunderstorm from causing an accident would make the aircraft too heavy to fly, because no one has duplicated the shields from the Starship Enterprise for commercial use, so those protections would not fall within the definition of ALARP. Also, if your organization cannot afford a mitigation, then that mitigation also does not meet the definition of ALARP. The risk that remains after reaching ALARP is called residual risk, the risk value that you should use in making your decision between accepting the risk and avoiding the hazard altogether. So, when should we do an SRM process? The FAA says that we apply SRM every time we implement a new system, we revise an existing system, we develop operational procedures, we identify a hazard or risk that we have not effectively addressed. Wait, what's a system? A system is an integrated set of elements that function together to produce a desired result. In FAA SMS terms, this means a coordinated and structured framework of people, procedures, tools, and policies working together to achieve safe operations. It's not just about equipment or technology. It's the full scope of how an organization functions safely and consistently. Now, let's go through the SRM process. First, have a process, which means that you have steps written down in your SMS manual. Second, define your system and its associated hazards. To keep it easy, Blue Skies Charter manages a Part 91 single-engine aircraft in the upper Midwest. The owner, a huge Brewers fan, wants to fly between Holland, Michigan, and Milwaukee for a baseball game. The most significant hazard associated with these operations is engine failure. How do we define the risks associated with an engine failure in this environment? As we said earlier, the likelihood of an engine failure is quite low, but the severity, which is most likely ditching, is high. If the engine should fail, meaning that we can accept the likelihood, but we must address the severity. From our previous discussion, there are several ways to mitigate the significant hazard of engine failure during these operations. One option is using a multi-engine aircraft for regular flights. However, this might not pass the ALARP test, as an operator likely already would use a multi-engine aircraft if feasible. Another possibility is flying at an altitude high enough to glide safely to land. For example, covering the 80 nautical miles between Holland and Milwaukee would require an altitude of about 27,000 feet to glide halfway across Lake Michigan. This isn't feasible in a single-engine aircraft with a service ceiling of 16,000 feet, thus failing ALARP. Alternatively, flying under Part 91 regulations without supplemental oxygen allows for cruising at 12,500 feet, providing an 18 nautical mile glide range. Flying parallel to the shore around the southern end of the lake and remaining within gliding distance would reduce the severity of potential engine failure, resulting in an acceptable residual risk. This option involves fewer than 200 total miles within the aircraft's range, making it ALARP compliant. Next, I must decide whether to accept this residual risk or avoid lake crossings entirely by routing around or chartering a multi-engine aircraft. All these options are acceptable. The decision rests with the operator's judgment. It's essential to document this safety risk management SRM assessment and periodically review it. Now, who needs to know about this SRM process, either in whole or in part? First, any pilot in the organization must know about the mitigations in place, such as flight planning routes and altitude considerations. Second, you should brief your passengers on the planned flight path and any necessary deviations so they understand the reasoning behind them. Third, if you are flying under IFR or through controlled airspace, you must advise ATC of any restrictions or specific routing needs so they can accommodate your SRM requirements. At Blue Skies Charter, effective safety risk management is central to every decision we make. By proactively identifying hazards, thoughtfully assessing risks, and implementing practical solutions, we ensure not only regulatory compliance, but, most importantly, the safety of everyone on board. Remember, safety isn't a one-time event. It's a continuous journey. We would like to extend our sincere thanks to the NBAA Safety Committee SMS Working Group for their contribution to this educational content, and to Aviation Safety Solutions for demonstrating their continued investment in safety education, dedicating the resources and expertise to make this video possible.